Okay, so today we're going to talk about the real number system. So let's go ahead and get out our Math Interactive notebook. And we're going to start writing. It's like the pen just wants to write. In our paper Math Interactive notebook on our table of contents page. Make sure you have that out. Move that off to the side. So we're in Unit 1. We're talking about the real number system. And that is going to be on page 1. I'm going to zoom in just a little bit here for you. So real number system, page 1. You want to go to page 1. Remember we had 3 more table of content pages after that. And we're going to mark this page number 1. So what is a real number? You've actually been using members or elements of the real number system since kindergarten, actually since before kindergarten. It's the first numbers you learned about. But a real number is considered a value of a continuous quantity that can represent a distance along a number line Okay, so that is a real number. It's pretty much all the numbers that you know. Then below real numbers, that breaks up into kind of 2 different types of numbers. One is irrational numbers. So use a different color for this. And irrational numbers are all real numbers that cannot be represented as a fraction. So some examples of that, the number pi, because that is never ending, non-repeating as far as mathematicians know right now, that would be an irrational number. Another example might be radical 2. If we put that into a calculator, again, we're going to come up with a decimal that's never ending, non-repeating, therefore cannot be represented as a fraction. So the second part that real numbers break into are what's known as rational numbers. And rational numbers are all real numbers that can be expressed as a quotient. Remember, quotient is answer to a division problem, or a fraction, which oftentimes when we have fractions, that also represents division. So that's kind of how those two match together. Symbolically, we represent that as A over B, where A and B are integers and B cannot equal 0. Now, some numbers that I know you're familiar with, but maybe you don't realize they can be represented as fractions, is the number 4, for example. So 4 can equal 4 over 1. Therefore, it is a rational number. or something like 2/5, which represents a number smaller than 1. 3.14, 0.3 with bar notation. All of those are members of the rational number family. The rational number family then breaks down into, so we're going to put, oh, I drew across the way there. We're going to put rational numbers. And everything underneath here is actually a member of the rational number family. We're just going to keep on seeing how things kind of narrow down. So we have integers, which is a rational number that can be written without a fractional component. And it can be positive or negative. So up above, we talked about how the number 4 can be written as 4/1. That would be a fraction. But because it could also just be written as 4 with no fractional component, that makes it part of the integer subset or the integer family. Rational numbers from there, then, if you think about what's left in some of the examples we have up here, we would also have fractions. So when you're a rational number, you break down into either be integers or fractions. And fractions are a numerical quantity that shows parts of a specific size. So even when we had the fraction 4/1, that would be like saying we have 4 of 1. So that would be a way to represent 4 candy bars. When you talk about 2/5, if we take something and divide it into 5 equal parts, we then have 2 of those parts still in our possession. So this tells how many parts a whole was broken into, and this tells how many of those parts you got to keep. So that is fractions. Next, we break down integers. And integers breaks down into negative integers, which has the same definition as integers up here, except it only means the negative ones, and whole numbers. So whole numbers are all positive integers. And the number 0. From there, we have whole numbers, and they break down into 0, which we know means no objects present, or we can say value present, and natural numbers. So natural numbers are all positive integers excluding 0. And sometimes people call these the counting numbers, because the first number you typically learn is not 0, but actually 1. When people are talking, oh, you're 1 year old, how old are you, right? And if we wanted to make a graphical representation of this, if we just drew a box, and we considered the box real numbers, right? We would break that apart to first be rational and irrational. And then inside rational, we have integers. Inside integers, we have whole numbers. And inside whole numbers, we have natural numbers. So for integers, we know the only part of integers that winds up going into whole numbers are the positive numbers and 0. Only ones from whole that go into natural are the positive integers. And we don't include 0. That's kind of a breakdown graphically of that. I'll put that up a little bit further. So that is the breakdown of the real number system. So after this, what you would like to do is you can either type this information into your digital notebook, or you can snap pictures of the different parts and insert the pictures into your digital notebook as well. There's also some additional guided practice problems that you need to do in there. So I'm going to go ahead and show you that really quick. So if we go back to your math interactive notebook, we've just taken the notes that occur on slide 3. Slide 4. And I gave you information about this page as well. And on this page is kind of like a graphical representation of that. So if you want to, you may want to go put examples in there. Based on this page, 6, you have to decide where these numbers go. And what you want to do is to go the furthest in that you can. The next page, there's just that same graphical representation, but in a different, it's organized in a different manner. So you tell me, where do the pieces go? And that is real number systems.